Okay, so you guys looked at the question during the break?
Kind of.
Kinda.
Yeah.
Sound good. All right. Now have you all worked out how you'll approach this? Okay, they say that a computer program simulates a simple guessing game. The program generates a random number between 1 and 10 inclusive, so both 1 and 10 are included. And the user tries to guess this number by entering an integer. The user continues to enter integers until the number generated and the number guessed are the same. When the numbers are the same, the program notifies the user and prints a count of the numbers the user guessed before correctly guessing the random number. Okay, so we want to know how much times the user guessed wrong before they got the random number. So let's see if we can write this out as we would write it out. Okay, they say write a C program. So having to write a C program means that you need to put include stdio.h, right? Include stdlib.h and include, because we're using the random number generation, time.h, right? So we have these three values, these three statements here. We'll have, of course, our time underscore t variable t, and you will get away without putting these things in there because really and truly this statement here is the only statement. This statement here is the only statement that is inside of the this statement here is the only statement that is necessary that they give you that goes with random numbers. But we know that we know how to do random numbers, right? So we have int mean. And we know that when we're doing a random numbers, we have srand, and we put unsigned time, right, ampersand t, right? And that would allow us to get our seed for our random number. Again, not necessary in this case, but we know it, so we put it. Okay? And then we could go int r is equal to rand mod 10 plus 1. Okay? You have to include this line because of the fact that they've given you this as your random number generator. If you didn't use your time underscore t and your srand line to seed it, CXC would still give you your marks. Okay? CXC would still give you the marks, but you know, the thing is we know it, so practice it properly. Okay, and this is where our random number was generated. And this should give us a random number between 1 and 10. Because we know that rand will give us a random integer. We mod it by 10, so that is going to give us a result that is between 0 and 9, but the range that they want is between 1 and 10. So that's why we add 1, because the lowest number in the range 0 plus 1 is 1, and the highest number in the range 9 plus 1 is 10. You all remember that, right? Yes or no?
Yes, sir.
All right, great. So when the numbers are the same, the user then tries to guess this number by entering an integer. So we can allow the user to enter some values, and we also need to keep track of some additional information, right? The amount of tries. So we could say tries is equal to 0, and we could say user underscore num is the user number. And for us to be able to do this here, we have to allow the user to enter the num. So we could say printf, common P, printf, right, please enter a number. And this will prompt the user to enter a number, but we know that in reality, we need to use scanf, %d, ampersand user underscore num to be able to save this number. So we ask the user for this number. We ask the user for this number, and right, we can actually at this point start a while loop. We can say while what? While actually at this point we also want to increase tries. So we say tries plus plus to increment the amount of tries. And then we say while user underscore num is unequal to R. If the user underscore number is unequal to R, what does that mean for us? It means that we have to ask the user to enter the number again. Right? So the user continues to enter integers until the number generated and the number guessed are the same. So if at this point it was the same, we would not go into this while loop. Right? When the numbers are the same, the program would notify the user. But if the numbers are not the same, we have to make the user guess again. Right? So we could say, we could be a little courteous and say printf, your number did not match. Try again. Okay? So we tell the user to try again. And then what do we want to do? We can put a backslash in there so that it'll come out on a new line. We have to ask the user to enter the number again. And because this signifies a new try, we are going to increment tries again as well. Okay? Why am I not getting to select? Right. So we could copy this, paste it here, allow ourselves to, okay? And this will continue to happen until the user number matches the random number generated. Okay? And once the user number matches the random number generated, then at the end here we could say printf. At the end here we can say printf, right? You have matched the number. You did it in %d tries. And put tries here. And put return 0 at the bottom here. And this is what Q6a is asking for with this question. So we simulate this guessing game. The line of code, right, generated the random number. That was at this position here. We generated the random number. We set tries to 0 and we set a value to take the user number into. We prompt the user for the number and we increase tries. If the user got it on the first try, then we will not go into here. If the random number was 8 and the user entered 8, try would have been 1 and this would have been false. So we couldn't go into the while loop. We would have just said, hey, you matched the number. You did it in 1 try. But if I entered 8 and the number was 6, this is true. It tells me you didn't match the number, try again. Please enter a number. And I enter 7 here, right? But the number, the random number was 6. 7 and 6 are different, so this is still true. So I go in again, and now I put in 6. And 6 and 6 match, So this no longer holds true, right? I will print out you have matched the number you did it in 4 tries. Any questions on this one? It's
So
pretty
and you have to
straightforward.
put
No, sir.
and you have to put the user the numbers that the user enters. Because that was in the question, I think.
The number that when the numbers are the same, the program notifies the user and prints a count of the numbers the user guessed. That's the tries.
Oh yeah, never mind.
Yeah, because the numbers that the user enter, we would see it on the console when they enter it, when they press enter to input the numbers. Okay? All right, so next question. All right. Oh, this paper had a pretty hard question in it. Kind of hard-ish question. But we'll do it because, you know, that's what the practice is about. So this question is related to various programming paradigms. What is a procedural language? A procedural language is what? Right? A language that executes program instructions in sequence and uses functions or methods in order to create specialized chunks of code. Okay, so that's what our procedural language is. Our procedural language goes step by step, and we have functions and we have methods that allow us to create specialized chunks of code. What is an object-oriented language? An object-oriented language does what? Anybody remember what we said it was? It allows us to model objects as real-world entities. Right? These objects have what? Anybody could remind me?
Attributes.
Attributes, yes. Which are its data elements. And it has what? And it has behaviors. Right? Which are its functions, which allow them to, these objects have attributes which are data elements and behaviors which are functions, which allow them to interact with each other. Understood? All right, so next question. This question was not that bad. It's 10.
So you could go back for a quick second, please.
Yeah. I'll send you the code. I'll send you this
thanks.
as well, eh? All right. I'll send you all it. I'll send it in the chat as soon as the class is finished. All right. See, like someone, you don't trust me, you know? Like, say he just send the documents, he just get it a week and a half later. Okay.
No, so it's not like that. More like a in the moment kind of thing.
Yeah. I don't have any problem. I just give him a little talk. All right. Because, you know, I still have the video from Tuesday to upload. So, all right. You have been commissioned to assist with the development of an application to keep track of district details for an upcoming general election. The data file constituency.txt stores the following district details: ID, name, population count, and the number of eligible voters. The format for this file is shown in figure 3 below. Data is terminated by a line containing the characters XX only. All right? So we want to read data from this file, count the total number of districts recorded, and find the district with the highest number of eligible voters. We could do this either using fscanf, or we can do it using the tokenization line method that you all are used to. Right? I'm a little more partial to doing this one with the tokenization line method, if that's fine with you all. Yes, no?
Yes, sir.
Yeah. All right. Some of you all probably sit down there rolling your eyes like, so you just go with whatever he says to go with. Right? But both are important for you guys to know. Okay. So remember with the tokenization, we want to read in data line by line. And notice what they say on this questionnaire. They say write C code. They didn't say write a program. Okay. If they say write a program, you start off with your include statements and you put main, and this is just the C code that will do these things. Okay? So watch your question. You might be wasting time in the exam writing program code when you really and truly just have to write C code. Follow me?
Yes, sir. Let me write that.
FT is equal to fopen. Fopen was the name of the file. Constituency.txt. Hold on, I have to go and plug in my laptop. My battery about to die. Oh, yes. Please give me 1 minute, please. My battery is about to die. You know, and you know it had something you were supposed to do during the break, but you didn't do it. I think plugging in my laptop was what I told myself. Hey, Mr. Valdez, do this during the break. And I did not do it. All right, so I am plugged in. And okay. All right, give me 1 second. This plug does not seem to be working. Excuse me. All right, I have to shift my whole orientation in terms of where I was facing, you know, to be able to plug in now properly. All right, so we're back. So we have file fp is equal to fopen. What do we want to open? We want to open constituency.txt, right? Constituency dot. And how are we opening this file? We're opening this file to read. So file fd is equal to fopen constituency.txt, read. And the next thing that we do is what? The next thing that we do is what, people? Anybody wants to offer us am I talking to myself again? No?
So I get array to read it in a line of data.
So you can have a character array, line.
Yeah.
Let's see, a line could hold 100. Okay, and we want to read it into line. So we want to say fgets, right? Fgets what? Right, we want to get fgets line, comma 100, comma from fp. So we read the line of text into the string line. And what do we want to do? We know that the line of text that should stop us from reading any useful data, right? The line of text that should stop us from reading any useful data. And just something to remember, I'm typing here. But when you are writing your solution, and your solution, of course, is on paper, leave enough space to stick more variables in on the top. So leave about 4 or 5 lines, right? Leave about 4 or 5 lines where you could stick variable names as you need to declare them off the top, because sometimes you don't think through, or you don't realize that you might need an additional variable at the beginning of writing all of this. It's easy to do on computer to just stick another variable to the top. But if it is that you are on on paper, then the paper, if you do this, right, you kind of leave yourself limited space to put in extra stuff. So that's just a little something to be mindful of when you're writing your exams on paper. Okay? Right, so we read a line of text from the file. And we want to make sure that that line of text is not XX. So how could we make sure that that line of text is not XX? We could say while strcmp fgets, sorry, not fgets, line, comma, and XX, right? Once these two don't match, so once this is unequal to 0, okay? Once the line of text is not XX. Okay, once the line of text is not XX, what do we want to do? Well, we want to read the data in from the file, and we want to count the number of districts recorded. So we have to be able to count int what? Int district count, right? DIS underscore count is equal to 0. So once that line of text is not XX, you could almost immediately assume that it's a valid district. So your district count could go up, right? Your DIS underscore COUNT plus plus, right? Increase the district count. Now you're going to have to tokenize this line of data to get the eligible voters, right? So the highest number of eligible voters. So I assume, keep track of the data file, so as the following details: ID, name, population count, and the number of eligible voters. So the data that we have to get is from this last section here. Okay? Because we are tokenizing, we need to tokenize away these three first before we could get this. And we want to get the name of the district with the highest eligible voters. So we need to store, right, high underscore district. Okay, we need to score high underscore district, right? Let's store the district code as well, right? So highest underscore district, let's give that about a size 25 in terms of the array size, right? The district code is, let's say about 5, right? And we want to get the highest, the highest underscore population, and we want to know, of course, the current underscore population, and we want to know the oh no, we're not storing the highest population. We just want to get the name of the highest district too, right? So the highest underscore eligible voters and the current underscore eligible voters. And we also want to get the current district as well, right? Current underscore district. Why do we have to have two separate variables for the highest district and the current district? Because we're reading in district by district, but we don't know if that is the highest district. So we have to save the highest district to a separate variable. And we're also dealing with the eligible voters. So we have to save the highest eligible voters to a separate variable from the current eligible voters. Because we could only read in Kingston first and say, okay, Kingston have 3,500 eligible voters. Then we read in Port of Spain, and we have to say, okay, is Port of Spain eligible voters higher than Kingston own? Yes, it is. But when we were reading Kingston, we didn't know the others. We didn't know if any other one would have been the highest. So we're going to make the assumption that the first one that we read in is the highest, and then for all other than the first one read in, we will check to see if it's higher. Okay? So we said increase the district count. So at this point, let's say we're starting from the beginning, we're reading the first line of text. And we say that as long as that line is not XX, we're counting that as a valid district. If the district count is 1, if district, actually no, before we do that, let's read in let's tokenize and put things in place, right? So we could say, we also need a token. So we could say token is equal to what? str line, token is equal to string tokenized line, right? And how do we want to tokenize the line? We tokenizing it according to a tab space. That look like a tab space or a space, right? So a tab space is, you put in \T for a tab space. So tokenize the line according to tab space. Tokenize the line according to tab space, right? And why are we tokenizing the line according to tab space? To get, you don't have to put these comments in for CX here. This is for me to let you understand what I'm doing. To get the city code. Okay, so we're tokenizing the line according to tab space to get the city code. And where we put in the city code, we put in that, we have to strcpy, right, that into curr underscore district. tokenize that and copy it into current district. What we putting in? We putting in that token that we just copied, right? So store the city code into the current district. And then we're doing the same thing for the city name. All right, the city name. We say token is equal to what? Is equal to strtok, but because this is not this is continuing on from that previous point where you tokenize, you have to put null. You have to put null, you put in back your \p, so that now we're going to get the district name. And this is the current district name. So again, we strcpy, we string copy our current underscore district name, right? So our current underscore district. Oh, I realized that I used current underscore district to store this. This was supposed to be district code. DIS underscore code, right? My bad. So the previous one was district code, and this one is current underscore district. And then we put in that token that we just copied inside of here, right? So you store the district name. And then we do the same thing for the population. Okay, at this point, I'm just going to copy and paste for speed purposes, right? And you're storing the population. So you're getting the token for the population, and but the population is not a string. The population is a number. So you say current underscore population is equal to, right, current on A to I, and you put in the token inside there. And it's the same for the current underscore eligible voters is equal to A to I, and we put in the token inside there. Okay? So this is where we store the current population, and this is where we store the current eligible voters, right? So we store all the data line by line inside of its proper place. And now we want to work out, because we've worked out a method of getting this data from the file, we now want to work out, well, how do I find out which city has the highest amount of eligible voters? Well, the first line of text read will always be the highest eligible voters, right? So the first line of text read will always be the highest eligible voters. So we could say if what? How do we know the first line read? We know that the first line is read when district underscore count is equal to 1. Right? So if this is the one and only district that we know about, if this is the one and only district that we know about, then what happens? Then this has to be, we will strcpy the highest underscore district, right? We'll copy the current underscore district name into the highest underscore district. So if this is the first city read, if this is the first city read, copy that city name into the highest district. Right? Copy that city's name as the district with the most EV. And that is because we don't know any other cities with the highest EV. And then we have to say the high underscore EV is equal to the car underscore EV, right? But if this is not the first city read, then I have to say else. So I say otherwise, and now I have to test to see if this current city EV is higher than the highest city EV. So I'll say if current underscore EV is greater than high underscore EV. So if the current city's EV is higher than the known EV, what do we want to do? Right? What we want to do is that we will make this city the highest city with the eligible voters. Okay? So we would say that high underscore EV is equal to current underscore EV. And we will do the same string copy that we did here before. Right? We'll save this city's name. We will save this city's name as the city with the highest EV. Right? So that's the highest district here. And this is it. So all we have to do at the end of this while loop, right? So this is the end of the while loop here. And sometimes I like to put a little end if here, so that I can keep track of this. And this would be an end while. At the end of this while here, I could print out what they ask for, which is to tell me the district with the highest number of eligible voters, right? And the total number of districts. So I could just simply say printf, the highest number of, sorry, let me start off with the number of districts are %d, right? And just that, sorry, would just simply be dist underscore count. And then I could say at the end here as well, printf %d, sorry, %s is the highest number of eligible voters with %d voters. Okay, and what I'm going to print out here is high underscore dist and curr underscore dist. You all with me on this one? Right? So this one was a little bit of work. This question was a little bit of work. But I think, you know, it's a pretty straightforward question. What you all think?
So, how many codes does come like in paper itself?
How many what?
Like codes, how many like codes that you have to write comes in the paper?
You'll get about I would say you'll get about 2 or 3 pseudocode questions. You'll get 2 code snippet questions and then 1 big code question. This is kind of like the big code question in the paper. Right? But you almost always get 1 question that asks either about structs or about file input output. You all with me? Any other questions? No? So we can move forward. Right, so this was a 10-mark question, and that finished question 5. Now we're on question 6. Right, now we're on question 6. Let's see how much of question 6 we could do. Question 6 I don't think is as bad as question 5. This question was kind of mean for 10 marks. Yeah, I'm not going to lie to you. Right? This was a bit much to have to do for 10 marks. And I'm not going to lie as well. If it is that you took the scanf approach, this code would have been simpler. So maybe next class we could take a look at the scanf approach with this question. All right, so question 6 is state 3 ways in which an application for a mobile device may be different from an application for a desktop computer. All of you could answer this question. So I'd expect one of you all to tell me ways in which an application for a mobile device would differ from an application for a desktop computer.
So it may not have like all the features, like
Right, so it would be right. So that's one way. Right. It may not have as many features as the desktop application. What's another way? Think about the interface. The interface for a mobile device application would be different. It would be a different interface as the mobile device uses touch and desktop uses mouse and keyboard. Right? And another way, right, is that it would be optimized for the different processor, mobile processor. So it will be optimized for the different, so it may be able to handle less requests. All right, that's kind of like the first one though. All right, so an application for a mobile device, and of course, it would be smaller in size, right, to install, because we know that mobile devices have much less, they have much less storage, much less memory, even though these days mobile devices are catching up because you can get phones with all up to 128 gigs and people selling computers now with 128 gigs, right? And it seems like the same, but it's still not the same in a kind of way because you could always add flash memory easily to your computer. Some of these phones not coming with the flash memory option to add and expand the memory, right? Like iPhones. Okay, so last question. Let's take one last question to look at. All right, so we can look at question 6b, which is where we have to create basically we have to identify some output for this code. Okay, what is the output produced by the following C code? All right, so we take a look at this code. Now this question was, as far as I remember, one of those questions where you really have to look at the variables there. So what you do, the best thing to do is to write down everything. So we have int test, B, int C, int A. So the function test, we have a function called test, and it returns the value of C plus A. Right? Let's see. Right. So it takes in A, B, and C. But look at what is going to happen here. When you pass A into test, it stores in B up inside here. B stores in C, and C stores in A. Right? So C plus A is really B plus C down here. What this question is doing is that it's tracking your ability to understand how variables are passed to functions. Okay? All right. All right. So we start off with the value of A. We have B and C. Right? A is 1, B is 2, C is 3. This is in main. Okay, this is in main. All right, and we could always just work out test in the corner here or something. So test. Right? When it's past it. So A is 1, B is 2, C is 3. While A is less than or equal to 10, we say for B is equal to C. So we override the value in B at this point. Right? B is equal to 3 at this point because we just overrode the value of B with this statement. B is less than or equal to 7, right? And B is equal to B plus 2. So we're going up from 3 to 7, right? Till it passes 7. Only after it passes 7, we can come out of this for loop, right? B is equal to B plus 2. And it goes up by 2 every time. So at this point, B is 3. And we say A is equal to test A, B, C. Right? So we say A, B, C. So in test, A takes the value of A inside of here I'm talking about, right? So for test, if we have A, B, C inside a test, the value of B gets what was in A, so the value of B is 1. The value of B was passed here, and that gets passed to C for test. So, right, the value of B, which is 3, gets passed to C, so 3. And the value of C, which is 3 also, gets passed to A. So this is 3. So we return C plus A. So we say what we're returning at this point is C plus A, which is 6. And what we're doing with that 6 is that A now becomes that 6, because that's what was done here. So we print out our output, and I'm going to simplify it just because I need space, all right, is that A is 6, B, right, A is 6, B is 3, C is 3. So that's what our output would have given. Okay? Then we say A plus plus. So A goes up to 7. Right? A goes up to 7. C minus minus. C goes down to 2. Right? At this point, we reach the end of the for loop. Is B yet at 7? No, B is not yet at 7, but it has to go up by 2. So the value of B goes up to 5. Right? So we go back into this A is equal to test ABC. What are the values of ABC? Right? The value of 7 gets passed to, so I'm erasing this. The value of 7 gets passed to B. The value of 5 gets passed to C. and the value of 2 gets passed to A. And it says here return C plus A. So 2 plus 5, right, is equal to 7. So we return 7 because 2 plus 5 is equal to 7. So the value of A, right, when it's returned from test, was 7. So it gets written over with 7, which it was previously. So we print out A is 7, B is 5, C is 2. Right? We say A plus plus, so A is now 8, C minus minus, C is now 1. Right? C minus minus, C is now 1. We end the for loop, but we can't come out yet because B is still less than 7. Right? So this goes to 7. Right? Because when we hit here, it's less than or equal to 7. So B is 7. 7 is equal to 7. So we can't move out. Right? So we have to go in. A is equal to test ABC. So we have to put these values in again. Right? What is in A goes to B. Right? So 8 goes inside of B. Right? The value of B goes inside of C. So 7 goes inside of C. And the value of C goes inside of A. 1 is inside there. So we return C plus A. So 7 plus 1 is 8. Right? So the value of A is now 8 again. That's when we return it. We print A is 8, B is 7, and C is 1. All right? We increment A. Did I forget to increment A last time? Could somebody tell me? Hello? Hello?
No, sir,
Did
I
I?
think it did, but it did to C minus minus just now.
You sure it's not? Because I think that's how I got 1 with C, but then I didn't increment A. Because A was 7 here, but then when I did the A plus plus, okay, 8, 8. Or did I do that? I think I did it. Anyway, let's go forward with it, right? So A plus plus, A would be 9. All right, A would be 9, C minus minus, C is now 0. And because we are at the end of the 4 here, we do the B is equal to B plus 2. So B is 9. So we come out of this loop. We come out of this for loop here, right, with B being 9. And then we have this statement, A is equal to A plus 2. So A goes from 9 till 11, right? And that's where the while stops because A is less than or equal to 10, 11 is greater than 10, so we can't loop once more. So this is where the values would lie. I'm thinking that I did increment A, but there might have been a mistake inside of there. So if it was, then we would have had a different value for A at the end, right? But this is where we have what you have to do in terms of this. So the output, this is what CXC is looking for right here, right? A is 6, B is 3, C is 3. A is 7, B is 5, C is 2. Right? A is 8, B is 7, C is 1. Hold a second, please. All right. Well, at this point, I will stop recording and just hold a second